Hello, my name is Michael Leamy and I'm a professor of mechanical engineering here at Georgia Tech. Today I'm going to talk to you about a patented two-scale command shaping technique for smoothly restarting an engine while mitigating chassis vibration. Our inspiration for developing this technology comes from start-stop features that are found on many vehicles today. What this feature does is stops the engine at a stoplight, then waits for the driver to move their foot from the brake to the gas pedal, and then restarts the engine, thereby saving fuel and emissions. Unfortunately, many drivers do not like the noise and vibration and harshness associated with this feature, and they defeat the mechanism, thereby eliminating the fuel and emissions savings. An additional motivation for this work comes from the desire of auto manufacturers to reduce the number of cylinders they use presently in their vehicles. For example, in the recent Chevy Volt, GM has come out publicly and said they would prefer to use a 3-cylinder engine in that application, but due to the noise, vibration, and harshness associated with engine restart, they had to go with a 4-cylinder engine. Our technique could potentially reduce the noise, vibration, and harshness associated with those 3-cylinder engines, and is in fact the reason we chose to look at a diesel 3-cylinder engine in our current experiment. In this technique, we have a patented profile that we send an electric motor to restart the engine. Essentially what we're doing is counteracting the torque pulses due to combustion, also the compression stroke, such that we're smoothly restarting the engine. In addition, we use command shaping to command the torque profile such that when we first excite a natural frequency of the system, a half period later we send additional torque pulses to counteract the vibrations we first start, in effect reducing the vibrations sent to the chassis and to the driver. In the current setup, we use 3-phase power coming from the wall to a Sevcon inverter, which then sends this 3-phase power to a 66 kilowatt Parker electric motor. We then command the torque of this electric motor such that we smoothly restart an internal combustion engine. In this case, the internal combustion engine is a 3-cylinder diesel Kohler engine, approximately 1 liter and 15 kilowatts of power. Note that we're only using about 10 kilowatts of the electric motor power in order to do this restart. As you can see in the experimentally obtained data, when we do a conventional restart, we see much larger amplitudes at frequencies than we do in the shaped profile restart. We feel strongly that this patented technology can significantly decrease the noise, vibration, harshness associated with start-stop features and improve consumer acceptability at little to no additional cost.